One type of distribution that is symmetric and bell-shaped is called a normal distribution. Mostly normal distributions come up with repeated sampling. So common with repeated sampling. I'll give you an example of that in a second. And there is some belief that certain measurements are normally distributed, like standardized tests, they attempt to make them normally distributed. So standardized tests, oops. Now, regular tests, so like if math for elementary school teachers, if there was a standard like exit exam for the geometry you learn in there, and we gave it to every student that takes math for elementary school teachers in the entire country, and we looked at the distribution of people's scores, we would find most people did average, some people did not so good, some people did really good. There'd be kind of a symmetric bell shape to it. It may or may not be normal. Normal is really a specific symmetric bell shape. So I just want to bring up a program here that's going to help us look at that. And I'll put this in the chat if you want to check it out. We've looked at it before. Stat key gives us a nice normal distribution grapher. And I'll put this in the YouTube video also. So I'm going to go down to what they call theoretical distributions and just show the theoretical version of the normal, and then I'll show a couple of examples of what I mean by repeated sampling leads to normal distributions. So this is the symmetric bell shape that's considered normal. Now, they actually come in many shapes and sizes, but they all have similar properties. And so the properties that they have in common are related to the numbers on the axis down here. So I'm gonna have this draw me a two-tail, and let's go, that's good enough right there. So imagine that this is just a histogram, but smoothed out like I was drawing before. The numbers on the axis right here are standard deviation. So we talked about calculating standard deviation in class before, about the mean being in the number in the middle. So this 0 right here is like my mean. And then this would be 1, 2, 3, 4 standard deviations. So this axis right here, the x-axis, is the standard deviation axis. So standard deviation. And remember, standard deviation is just a measure of the average spread from the mean, and we say the mean is the middle here. So I'm just going to draw a line there for my mean right down the middle. This 0.95 in the middle means that if we look 2 standard deviations to the left and 2 standard deviations to the right, and we count up everything in the middle, we're going to find 95% is within those 2 standard deviations in this white region right here. Okay. So let's note that. Oops, it's not a pen. 95% of data should be within 2 standard deviations of the mean. So if the mean is 0 and I look 2 to the left and 2 to the right and I count up everybody that's in the middle here, it's going to be about 95%. If we were to do that again, but only look 1 standard deviation on each side, so I look at all the histogram bars that are in between this region right here. So I think I'll highlight this one. So I kind of count up all of the stacks. Oops. In here. So this would be within 1 standard deviation of the mean. We would find that about 68% live in that region right there. Oops. Okay, and just take a look at the calculator. So if I come down here on the standard deviation, on the, the normal distribution calculator and stack key, all of these numbers are clickable. So I can click on them and pick a new one. So if I click and type -1 there, okay. And again, I was on the 2-tail checkbox already. It says that if you look 1 standard deviation to the left and 1 standard deviation to the right, and you count everything in between there, you should get about 68%. Now here it shows 68.3. If we go back to -2 on that side, because I click 2-tail, it matched a 2 on the other side. It says it's about 95%, 95.4. If we look 3 standard deviations on each side, then it's about 99.7 within 3 standard deviations. So in general, most data is within 3 standard deviations. So an example of that I can give. New page. Think about human body temperature. What do we think average human body temperature is? Anybody? Come on, somebody knows this, I'm sure of it. Happily, Brianna, Lauren, help me out here. Average human body temperature. Well, this is awkward. Is anybody still alive out there? I don't hear any voices. Oh, okay, Brianna's alive, but nobody wants to claim they know what human body temperature is. All right, how about I give it a shot? Most people take it to be 98.6 degrees Fahrenheit. That would be the mean. Population mean is called mu. Standard deviation is believed to be about 0.7 of a degree. So if I were to graph that out, and it's also believed to be normally distributed. So let's see what that means. If it's normally distributed and we get the body temperature of thousands and thousands of people and we made a histogram of it, we'd find that right in the middle, we would see 98.6. And then if we looked out, 1 standard deviation to the right, 2 standard deviations to the right, 3 standard deviations to the right, that means we're jumping by 0.7. So that would be 99.3 and then 100 and then about 100.7, if I did that math right. If we go the other way, 1 standard deviation to the left means we'd subtract a 0.7. So that would be 97.9. And do it again, subtract 0.7. That would be 97.2. And we do it again. That would be 96.5, I think. So the standard deviation graph said that if you look 3 standard deviations on each side, so this would be -3 standard deviations on the left, this would be +3 standard deviations on the right, then we would find that 99.7% of people should have a body temperature somewhere between 96.5 and 100.7. If somebody has a temperature out here, they're an outlier. Either they have just an unusually high body temperature compared to everything else, or maybe something's wrong, a fever, they're sick. And typically doctors consider a fever something to be over 101, a fever to be concerned about, that there's something wrong and that we might want to try to moderate the fever. But just indication, because we've looked at human body temperature for so long, we know the usual range, and it turns out it's normally distributed. All right, I think that's more than enough for today. Let's go back to my desktop, take a look at my outline. So we're going to review some of this stuff next class. 7.3 is the section we were going over today. We took a look at the idea of randomness. We'll look at that again next class. Distributions, we'll review some of that again next class. The idea of this normal distribution and the different percentages related to standard deviations. And we definitely look at some more examples of how it relates to the mean and standard deviation, when we can use a normal distribution and when we can't, and the idea of a z-score and rare events. So I've touched on almost everything here. There's some homework based on this stuff here. Make sure you do the reading and the reading quiz soon. Otherwise, we'll go over this stuff again next class and then do the activity, or at least something very similar. So that's it for now. Take care, do good math. I'll see you in the near future.